Okay, so in this question, we're asked to find the area of a square, given certain information. I think this is an opportunity to pull out our formula chart and just remind ourselves of some relationships with squares. So I'm going to go grab that real quick. Okay, so as I'm looking at the reminders here, I'm told that the relationship in the perimeter is that it's 4 times the side length, and the area is that same side length squared. Okay, so then I'm going to go back to my question. And in our question, we're told that the area, there's 312 meters of fencing. Okay, so is that 312 perimeter thing or an area thing? And hopefully when you think about it going on the outside of the surface, you realize that that's a perimeter thing. So that's that 4L equals the 312. And I want to figure out what each length is. So what do I need to do to the 312? I need to divide that by 4. And so I'm going to pull up a calculator here, Excel. 312 divide 4, yay, and I get 78. Alright, so from here, then I want to go think back to what that area formula is, and the area formula was length squared. So the area of this particular square would equal 78 squared, which, and going back to our calculator, helps if I type equals, is 6,084 square feet. So 6,084 square feet. Okay, so let's talk about this question real quick. We're given a lot of information, a lot of percents, and it says there's a 95% chance that between 53% and 59% of voters will vote for Congressman Bob in the next election. What do you know about the sample statistics and the margin of error in the survey? Okay, so learning something new is interesting. In order to get a student to remember the information, we have to, as educators, we have to, as teachers, for lack of a better way to describe this, annoy our students. We have to challenge what they think is true and force them to accept that maybe their understanding of the world is a little off and that there's some new information that maybe they've never really considered. And so what I'm going to ask you to do is I'm going to ask you to pause the video and go look in your notes for where the ideas of sample statistics and margin of error would have been covered. So kind of think back, start in your mind and think back to, was this the first unit, second unit, third unit, fourth unit? And then additionally, think about which lesson maybe this would have come from. So I'm going to throw you some information here in a second, but the fact that you go look it up is going to wake your brain up, because your brain's going to go, that's annoying that he's asking me to go look this up. I'm actually going to have to go do something. And so your body's moving and you're physically going to go review this information. And then when I put it up there, your brain's going to go, you know what, I'm just going to learn this. It's much easier to go and look it up. But if you go look it up, you'll remember it easier. If you just wait for me to pop up the answer, it's not going to stick in your head as easily as it would if you actually take some effort. So seriously, go pause it, see if you can find where we would have covered something like this. Okay, are you still here? Did you go look? All right, no, actually pause it and go look. Okay, here we go. Here's what you should have found. Okay, so this actually came from the first unit in the sample discussion. That was the same lesson where we talked about stratified sampling versus convenient sampling. All those different sampling methods is when we would have encountered something like this. Okay, so just kind of walk you through what we're looking at here. We are looking at what's called a confidence interval, and so this number, this 53 and 59%, would be what's considered to be the endpoints of the confidence interval. So normally it looks like something like this. Okay, and then they give us a little bit of reminder in the definition that there was a sample statistic where we added something, and that got us the 59, and there was another sample number that we subtracted something, and that got us the 53. So we have to kind of think for a second. Is there a number sort of in the middle of 53 and 59? And that we get by simply finding the average. So if we add them up and divide by 2, that'll tell us what this middle number is. So let me go jump to an Excel spreadsheet and do that. Then I want to take that number and divide by 2. Okay, so that's 56. So this little sample thing, there's a 56 there, and there's a 56 here. And then what do we add to 56 to get 59? Hopefully you figured out that that's a 3. And then consequently that makes sense that it's a 3 there. Okay, so what are these things? Our sample statistic is the 56%, and our margin of error equals 3%. Now, I'm not one to walk away from a statistics conversation, so let me one more time try to talk to you about what all this means. So if I want to actually see what's going on in the population, I can't talk to everyone, but if I carefully pick my sample, if I randomize and I get what are equal representation of all different subsets of the population, meaning I talk to all ethnicities, I talk to all socioeconomic ranges. I talk to really rich people, really poor people, I talk to majority, minority, and I get a real good sample as far as what's out there in the population, and I ask this question of them, that can give me an estimate of what the population is going to think. So that sample statistic merely means that the 100 people I talked to, 56% said they will vote. Margin of error is a number we get based on the sample size. So how many people did we actually go out and talk to? Now, in our class, we don't worry about the calculation of where they got the margin of error from, other than what do we do with it. So when we get a sample statistic, we plus or minus the margin of error. That gives us the interval, the confidence interval, and gives us an idea about what the population is going to do. The intent in this question is that there's not just a yes or no answer. The intent is to get you as the student to do some critical thinking and actually look at why certain questions are helpful and certain questions are not. So we're given this scenario, and if you haven't read it yet, go ahead and read it. But the gist of it is we've got a Proposition EZ proposes to raise the state sales tax by 0.25%. The proceeds will be earmarked for music education in public schools. If you want to determine whether or not it will pass, which of the following survey questions will give you the most accurate results? Briefly describe the problem with the other choices. Okay, so when we talked about statistics and sampling, one idea we talked about was bias. So bias is phrasing a question or creating a situation where we're influencing the types of answers we're going to get. In other words, if a question is just truly biased, we know what most people are going to answer before we even go out and collect data, and thus we're kind of manipulating what the outcome is supposed to look like. So as we go through these questions, we're trying to identify the bias. Which ones will influence outcomes, and which ones are good questions but maybe not actually answer what we want. So here's what we want. We want to know whether or not people are willing to pay more money. Are you willing to give more taxes to pay for something? So that's what we want. We essentially are going to vote for this. Okay, so let's go through our 4 questions here. Do you know which proposition will raise taxes for sales tax and fund education? Okay, so for starters, this is a straight up yes/no question, which could be good or bad, but knowing the proposition doesn't tell me whether it will pass. So knowing about the proposition is not a promise the voter will support it. Just because they know what it is doesn't mean that they are going to vote for it. Question 2, B, will you vote for Proposition EZ, which will raise the amount of sales tax that you pay every year? Okay, so again we get a yes/no question. So are they going to support it? And we're essentially told the consequence of it, which is going to add bias. And you think, well, why would that add bias? Well, if you just simply say, hey, are you willing to pay more for taxes? People are going to say no. That's going to generate more no responses. So it emphasizes that taxes will increase without knowing why. Okay. Question C. Do you believe that music education is important? Okay, again, this is a yes/no question. This is generated to produce yes answers. Most people are going to say, yeah, I think music education is important, but it does not tell us if the voter themselves will support the proposition. So it does not give information about if the voter will support the proposition. Okay, so I really hope this last one is a good one because the other three are not looking too hot for me. Are you planning to vote for Proposition EZ, which will raise state sales taxes and support music education? Okay, so we have a yes/no question, and voters are informed it will raise taxes and support music. So this is the most fair question. They're told what will happen and what it's for. And so a yes here will definitely tell you if they're going to support the proposition, and a no will definitely tell you an informed decision. So this, so I got rid of my D here, bring it back. Okay, so this is the best, this is the least biased question.